Activity 1.1 Burning of a magnesium ribbon in air and collection of magnesium oxide in a watch glass. First step is clean a magnesium ribbon about 2 cm long by rubbing it with sandpaper. Second step, hold it with a pair of tongs, burn it using a spirit lamp or burner and collect the ash so formed in a watch glass as shown in figure 1.1. Now burn the magnesium ribbon keeping it as far as possible from your eyes. What do you observe? As we know, magnesium is a very reactive metal. When it exposes to air, it reacts with oxygen to form a layer, that is magnesium oxide on its surface. Mg plus O2 gives 2 MgO. This layer of magnesium oxide is quite stable and prevents further reaction of magnesium with oxygen. Okay, now why should a magnesium ribbon be cleaned before burning in air? The magnesium ribbon is cleaned by sandpaper to remove this layer so that the underlying metal can be used for the reaction. Let's start with activity 1.3. Take a few zinc granules in a conical flask or a test tube. Second, add dilute hydrochloric acid or sulfuric acid to this. Now, do you observe anything happening around the zinc granules? Touch the conical flask or test tube. Is there any change in its temperature? Zinc reacts with dilute sulfuric acid to form zinc sulfate and hydrogen gas is evolved. This is a single displacement reaction of a non-metal by a metal. The zinc will react with sulfuric acid, forming zinc sulfate dissolved in solution and releasing hydrogen gas. In this figure, we can see that there is change in state, change in color, evolution of a gas, and change in temperature. An important note is to take precaution and handle the acid with care. Let's start with activity 1.4. First, take a small amount of calcium oxide or quicklime in a beaker. Second, slowly add water to this. Third, touch the beaker as shown in the figure. Fourth step, do you feel any change in temperature? Well, calcium oxide reacts vigorously with water to produce slaked lime, releasing a large amount of heat. In this reaction, we can see that calcium oxide, which is also called quicklime, and water combines to form a single product, which is calcium hydroxide, which is also known as slaked lime. Such a reaction in which a single product is formed from two or more reactants is known as combination reaction. Do you know, when calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls, calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. It is interesting to note that the chemical formula for marble is also CaCO3, which is calcium carbonate. Let's start with activity 5, which is decomposition reaction. First step, take about 2 grams of ferrous sulfate crystals in a dry boiling tube. Second, note the color of the ferrous sulfate crystals. Heat the boiling tube over the flame of a burner or spirit lamp as shown in the figure. Last step, observe the color of the crystals after heating. Now in this reaction, you can observe that a single reactant breaks down to give simpler products. This is called decomposition reaction. Ferrous sulfate crystals, which is FeSO4, 7H2O, lose water when heated and the color of the crystal changes. It then decomposes to ferric oxide Fe2O3 and sulfur dioxide SO2 and sulfur trioxide SO3. Ferric oxide is a solid while SO2 and sulfur trioxide SO3 are gases. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime. It has many uses. One is in the manufacture of cement. When a decomposition reaction is carried out by heating, it is also called thermal decomposition. We can see here that CaCO3, which is limestone, when heated gives quicklime and CO2. CaO is solid and CO2 is gas. Let's start with the sixth activity, and the activity is thermal decomposition reaction, which is a very important reaction from exam point of view. Now, first step, take about 2 grams of lead nitrate powder in a boiling tube. Second, hold the boiling tube with a pair of tongs and heat it over a flame, as you can see in the figure 1.5, and the color of the fumes is brown, not blue. Third, what do you observe? You will observe the emission of brown fumes. These fumes are of nitrogen dioxide, NO2. The reaction that takes place is 2Pb NO3 whole twice, which is solid, and it is called lead nitrate. When it is heated, it gives 2PbO, lead oxide, and 4NO2, which is nitrogen dioxide, and it is a gas, and it also gives oxygen, which is also a gas. Now let us perform some more decomposition reactions. The first step is take a plastic mug, drill 2 holes at its base and fit rubber stoppers in these holes. Second, connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Now take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. Now you will observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tubes. Now is the volume of the gas collected the same in both the test tubes? Once the test tubes are filled with the respective gases, remove them carefully. You can also test these gases one by bringing a burning candle close to the mouth of the test tubes. This step is also known as electrolysis of water. Okay, why is the amount of gas collected in one of the test tubes in activity 1.7 double of the amount collected in the other? Name this gas. Well, the answer is during the electrolysis of water, hydrogen and oxygen get separated by the electricity. Water H2O contains 2 parts hydrogen and 1 part oxygen. Since hydrogen gas goes to one test tube and oxygen goes to another, the amount of gas collected in one of the test tubes is double of the amount collected in the other. Now let us start with the 8th activity. The first step is take about 2 grams of silver chloride in a china dish. Place this china dish in sunlight for some time, as shown in the figure. Now observe the color of the silver chloride after some time. You will see that white silver chloride turns grey in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. You can see in the reaction that silver chloride, when exposed to sunlight, turns into grey in sunlight to form silver metal. The same is with silver bromide, which also behaves in the same way. When 2 silver bromide is exposed to sunlight, it gives silver plus bromine. We have seen that the decomposition reactions require energy either in the form of heat, light, or electricity for breaking down the reactants. Reactions in which energy is observed are known as endothermic reactions. Now the next activity is displacement reaction. First step, take 3 iron nails and clean them by rubbing with sandpaper. Second, take 2 test tubes marked as A and B. In each test tube, take about 10 ml copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep one iron nail aside for comparison. Now after 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solutions in test tubes A and B. Now compare the color of the iron nails dipped in the copper sulfate solution with the one kept aside. Now, why does the iron nail become brownish in color and the blue color of copper sulfate solution fade? The following reaction which you can see is when iron has displaced or removed another element, copper from copper sulfate solution. Now you can see that in the reactivity series, iron is more reactive than copper. So iron has displaced or removed another element which is copper from the solution copper sulfate and has become FeSO4 which is iron sulfate plus Cu which is copper. This reaction is known as displacement reaction. There are other examples of displacement reactions below. When zinc and copper sulfate reacts and gives zinc sulfate plus copper. And another is when Pb plus copper chloride which is CuCl2 gives PbCl2 which is lead chloride plus copper. Zinc and lead are more reactive elements than copper. That is why they have displaced copper from its compounds. Now let us take another reaction which is also called double displacement reaction. The first step is take about 3 milliliters of sodium sulfate solution in a test tube. In another test tube, take about 3 milliliters of barium chloride solution. Mix the two solutions as you can see in the figure. Now what do you observe? You will observe that a white substance which is insoluble in water is formed. This insoluble substance formed is known as a precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. Now what causes this? The white precipitate of BSO4 is formed by the reaction of sulfate ions and barium ions. The other product formed is sodium chloride, which remains in the solution. Such reactions in which there is an exchange of ions between the reactants are called double displacement reactions. Now this is a very important activity. Take about 2 grams of barium hydroxide in a test tube. Add 1 gram of ammonium chloride and mix with the help of a glass rod. Now touch the bottom of the test tube with your palm. What do you feel? Is this an exothermic or endothermic reaction?